So the next chapter is on inverse trig functions. Just like the logarithmic function. Oh, by the way, will there be logarithms on this test? Yes. So if you did last night's homework, then you will know there is. I'm going to tell you that problem is on the test. So make sure you study that one. Anyway, inverse trig function. So here, let's start with the cosine graph. What does the graph of y equal cosine x look like? Whoop. 1, 2, 3, 4. 1, 2, 3, 4. So that's negative 2 pi, 2 pi, 1 and negative 1. So doesn't it look like this? And it keeps on going, right? Keeps on going. What if I told you graph the inverse of this? Have we forgotten how to graph inverses? You switch the x's and the y's. So, come on, you guys did this last year. In fact, because I'm teaching this 5th grader trigonometry right now. And we're using the same book you did, trigonometry. This is exactly what was in the book. So I know you did this last year. So what is that point right there? 0, 1. So what happens when you switch the x's and y's? You get 1, 0. What about this point? Pi over 2, 0. So switch it, 0 pi over 2. What about that point? Pi negative 1. So if you switch it, you get negative 1 pi. And if you just keep switching all the x and y coordinates, you get a graph that looks like this. And it keeps on going up and down, right? But what's the problem with this? What did you guys learn last year? This is not a function. So what did we do, or what did you do last year to make it a function? Come on, man. You erase. So what's the standard way of restricting the range so that it is a function? You know what? I'll just tell you, because some of you will say, what? We learned this last year? So if I erase the graph and only keep the part that's between 0 and pi right there, now is that a function?
Yeah.
Yes, that's a function now. So what you need to do is you need to restrict the range. And I hope you guys remember that that's the key to doing inverse trig functions. That is like, if you don't know the range, it's all over. Okay, so there you go. So, what is this graph? Well, if you switch the x's and y's, you get x equal cosine y. But just like with logarithms, there's no algebraic way of solving for y. So somebody had to invent notation. So we call it cosine inverse x. It's the inverse of the cosine function. And that negative 1 does not mean 1 over. It means inverse. And what was the other way you can write it? Arc cosine x. They both mean the same thing. It's the inverse of the cosine function with the restricted range. So you have to do this with all 6 trig functions. So to make it easier for you, there's only 2 restricted ranges that you need to know. One is 0 to pi. Does that sound familiar? Or did you guys just memorize the quadrants last year? I don't remember anything from last year. And the other one is negative pi over 2 to pi over 2. That just makes it easier to memorize. So which inverse trig functions has this as the restricted range? Well, we just found out cosine inverse, secant inverse, and cotangent inverse. Which inverse trig functions has this as the restricted range? Well, it would be the other 3. Sine inverse, cosecant inverse, and then tan inverse. Okay, so this is all I'm going to cover today, is just the graphs. Okay, so I'm going to teach you the graphs, and the homework is not until next week, Monday. Okay, and then of course, what's going to happen? You got to do things to these graphs. Okay, so you got to get these basic graphs down. So how would you graph sine inverse then? Now, I don't know what you guys did last year. I don't know if you guys just memorized. Did your teacher make you responsible for the graphs? Who knows? Okay, so here, I'm going to teach you how to graph it, because you got to know this for calculus. We first put in the range, negative pi over 2 to pi over 2, and then that's 1 and negative 1. And then what you do, see, because I don't know, every single year students try to memorize these, but you don't want to memorize them. That's just more things to memorize. What are you going to do, memorize 6 more base graphs? I guess you can if you want to. And then what you do is you think of the graph of sine. Here's the graph of sine. Okay, what is that point right there? 0, 0. Switch it. You get 0, 0, because the inverse means you're just going to switch the x's and y's. What about that point right there? Really? Pi over 2, 1. So what happens when you switch it? 1 pi over 2. What about this point over there? Negative pi over 2, negative 1. Switch it. Okay, there you go. And then there's the graph. That's what the inverse sine graph looks like. Basically, remember, if you kept graphing, it would just keep on going up and down, but it wouldn't be a function. So when you restrict the range, then it becomes a function. So this is called y equals sine inverse x, or some books like to go arc sine x. When I write problems, I use both. And next year in calculus, they're going to use both too. Okay, what about secant inverse? Well, do you remember how you graph cosine? I mean, okay, here's cosine. How did we graph secant? What did we do? We humped the graph. Whenever the graph touches the x-axis, you put a vertical asymptote, and if the graph humps down, you hump up, right? Right? So what do you think we're going to do with the inverse? Instead of humping up and down, we're going to hump left and right because it's the inverse. So we're going to do like the exact opposite thing. Okay, let's do a different color. Now, when the graph touches the y-axis, there's going to be a horizontal asymptote. You guys understand? Because you're switching the x's and y. So over here, the graph is humping to the left. So now you hump right. It's humping right. So now you hump left. That orange graph is the secant inverse graph. All of these should be on your calculator. Oh, one thing bad about your calculator, it graphs cotan inverse wrong. Because I don't know how they programmed it, but it's not right. So if this is the graph of sine inverse, how do you think you would graph cosecant inverse? You hump it, except you hump it left and right. Whenever the graph touches the y-axis, there's going to be a horizontal asymptote, and if it humps left, you hump right. If it humps right, you hump left. Right? Because look, in the regular sine graph, how do you graph cosecant? Whenever it touches the x-axis, right, you put a vertical asymptote, and if it humps down, you hump up. If it humps up, you hump down. So we're just doing the opposite, hump left and hump right. Okay, what about, okay, which one you want to do first? Let's do tan inverse. Okay, put in the range. Okay, I'm telling you right now, this is the key to the whole chapter. If you don't know these ranges, you're going to fail it. I think last year you memorized it. Okay, now, think of the graph of tangent. What does the graph of tangent look like? Here's negative pi over 2, here's pi over 2. Does it go up or does it come down? You better know this for Monday. Because there's going to be one graph. I'm going to give you the graph. I don't know which one it is, but you're going to have to write the function. Okay, now, so if x equal negative pi over 2 and x equal pi over 2 are asymptotes, then if you switch the x's and y's, wouldn't it be y equal negative pi over 2 and y equal pi over 2? That's what an inverse is. You switch the x's and y's. What is this point? 0, 0. Switch it. What is this point? Pi over 4, 1. So what happens when you switch it? 1 pi over 4. What about this point? Negative pi over 4, negative 1. So switch it. Negative 1, negative pi over 4. So the graph looks like this. That's what the tan inverse graph looks like. And then cotan inverse, you do, here, I'll label it for you. You do the same thing. Okay, remember the range. What is the range? Just look right here. It's 0 to pi. And then think of the graph of cotangent. Here's pi. It looks like this. Switch the x's and y. So if you have vertical asymptotes at x equals 0 and x equal pi, what happens when you switch? You're going to have y equals 0 and y equal pi. What is that point? Pi over 2, 0. So switch it. 0, pi over 2. What about that point? Pi over 4, 1. So switch it. 1, pi over 4. And then look, connect the dots. And that's what the graph of cotan inverse looks like. So these are your 6 base graphs for the next chapter. And you can probably guess what's going to happen. What's going to be on the quiz on this? I'm going to pick one of them, and yes, you're going to, this is the last chance you have to get it right, you know. We've been doing this, is going to be like the 5th time. So what do I do first? Do I shift it first or reflect and shift? Well, it's just a matter of how you think about it, right? So anyway, that's going to be your homework on Monday. Take these 6 base graphs and do things to them. Okay, any questions of this? You don't remember these in your book? I don't know, maybe your teacher said, no, well, you'll take care of it next year? Well, this is the class where we take care of everything. All right, I want to show you some problems that are going to help you on the test. I have it right here. But first, I already told you, I think I told you already, that I took off, there were like 5 or 6 problems where you had to extend your knowledge. I took them off and I replaced it with more basic problems. So there's 14 problems. So the 2 choices were, I'll make them 6 points each, and then you get 16 free points. Or I can make it 5 points each, and then you'll have 30 free points. A or B? How come now you speak up? Okay, I'll do B, that's fine. Yeah, but 30 free points, you still gotta earn quite a bit. Okay, so here is one of the problems that I took off. Let's see if we can do it. Compute this value, 2 tangent. Now this isn't really that bad. It's just that it's tricky. This problem has been on the test the last 30 years because it's really neat. But every year, I would say 2/3 of the students get a fatal error. You know why? They go, hey, use somebody. That's the double angle identity, right? No, it's not. That's a plus sign. See, if you don't know, I'm telling you, identity failure is a fatal error now. You get the wrong identity, fatal error. If that was a minus sign, it would be the double angle identity, but that's not a minus sign. Anyway, think about it. Why would I put a problem that easy on the test? Well, maybe for your test, it'll be easy because they took them off. So how would you do it then? How would you do this problem?
Half angle.
Half angle? Well, okay. So you can compute tangent pi over 8 by using a half angle identity. How long would that take you?
A little while.
2 minutes. Plug it in here and then compute. Yeah, but I'll tell you from experience, the people who try that, maybe 1 out of 4 might get it right, because there's a lot of algebra, because there's going to be all kinds of radicals. Maybe there's a better way, like, hey, use somebody. That's secant squared. I hope you guys know that. You guys better know all the identities. You can bet I'm going to test you on every single one. And then now, that doesn't look like anybody, Mr. Park. Well, maybe if you change everything to sine and cosine. Like I told you, you get stuck, change it to sine and cosine. So what is tangent? Sine over cosine. And then what is secant squared? 1 over cosine squared. And then, of course, when you divide by a fraction, that's like multiplying by the reciprocal, right? Correct?
Yes.
Okay, let's get rid of this. Hey, I can cancel this with one of those, and then look what's left.
Oh.
2 sine cosine. Hey, you somebody. Look, I can recognize. Do you recognize 2 sine theta cosine? If you did last night's homework, how many times did that come up? About 5 or 6. Yeah. 2 sine theta cosine theta. That is the identity for sine 2 theta. So if this is theta, what is 2 theta? Pi over 4. Final answer, root 2 over 2. I don't care how you do it. You can use half angle, plug it in. You better get root 2 over 2 as your answer. That's the thing. But for those of the people, I don't know why, even though the students knew better, they still did the double, they thought it was double equiidentity. Are you guys like that too? Boy, you're lucky I took it off. Here's another one I took off. This one requires a lot of extending. What is the smallest value of x? Here, just do this. Find the smallest positive value of x such that, and then I give you an equation, 8. I wrote it down right here. I don't think I could memorize this. Okay, this problem has been on the test the last 20-something years too. But I took it off. Because I remember the last 4 or 5 years, only a handful of students get it. Okay, how would you even begin solving this equation? What would you do? You gotta do something. Yeah, factor. What can be factored out? 8 sine x cosine x, right? What's left? Cosine to the 4 minus sine, oh, sorry, this is a fifth. Sine to the 4. Maybe that's why you guys are confused. Okay, you don't get any points yet. Is it completely factored? No, you can factor that some more. That's a difference of squares. Okay, factor that. Cosine squared minus sine squared times cosine squared plus sine squared. Hey, you somebody. Really, that's the easiest one. That's 1. Hey, hey, you somebody. Cosine 2x. Hey, you almost somebody. Yeah, if there was a 2 there, I would be in the money. But Mr. Parkin said 8. Well, just make it 4 times 2 then. And then, hey, you somebody. That's sine 2x. Okay, so this is what we got so far. Okay, let's just rewrite it. Mr. Parker would have given up already. Hey, you almost somebody. If there was a 2 there, I could do something with it. Yeah, that's right. So split the 4 up into 2 times 2. You somebody. What is the identity for sine 2 sine theta cosine theta? Sine 2 theta. And then how do you solve an equation like this? Come on. Divide by 2. Is 1/2 a number I'm supposed to know for sine?
Yes.
Okay, so sine of what angle is equal to 1/2? Pi over 6. Okay, do I need to go 4 times around?
No.
No, because read the directions. It says find the smallest positive value. So you only need to work with this one. So how would you solve for x? Pi over 24. How many of you think would have got it? Well, then that would just be a -5 then, right? Mr. Park, 95 is a darn good score. Yeah, it is actually. Okay, this problem, okay, I already told you, logarithms are on this test. Why would you think it wouldn't be? It's on trig 5. You make sure you do that problem. The magic number is on the test. Sums to products, products to sums, that's all on the test. And this one is definitely on the test. So you're gonna have a whole bunch of equations to solve, maybe about 5 or 6 of them. And then I'll give you a restriction between 0 and 2 pi. Except one of them's gonna be an inequality, like this. Did you see the inequality on trig 5? Some of you are thinking, don't worry, Mr. Park, I'm gonna do it by Monday. I worry. No, let's just go less than. We don't need or equal to. How would you solve, how do you solve inequalities? You make one side 0 and you factor it. Just like you solve an equation, except you gotta make a number line. So how do I factor this? There's only one identity for that. I would venture to say almost every single problem is going to include some kind of identity that you got to use. And what can I factor out? So this would be considered a basic problem because there's really no tricks. You just got to do it. Okay, make a number line. What goes on this number line? What makes this 0? Pi over 2 and 3 pi over 2. See, this is where, if you don't know your trig values, this problem could take you 15 minutes just by itself. What about this? What makes this 0? When sine x is equal to 1/2. Pi over 6 and 5 pi over 6. Okay, so if this were an equation, that would be your answers right there. But it's an inequality, so what you do is you put them on the number line and you got to test. Now there's 5 regions right here. What's a good number to pick here? 0, right? Plug in 0. Cosine of 0 is 1, that's positive. Sine of 0 is 0. 0 minus 1 is negative. If you have to write that down, write it down to help you. Positive times negative is negative. And then what? Is there a pattern, like it alternates and things like that? How do you know? Because I told you on the video. This is not a polynomial. It doesn't follow that pattern. So anytime you make a number line with like trig or logs or exponentials, you have to test every single region. There is no pattern. You guys understand that? But every year, there's always a few clowns that want to just make it alternate. Well, there's one shortcut you can do. If you plug in 0 and you get negative, then if you plug in 2 pi, you should get negative also, right? 0 and 2 pi should give you the same thing, right? But that's the only thing you can do. You got to test. What's a good number to plug in over here?
1.
Huh? What's between pi over 6 and pi over 2? You got 2 choices, either pi over 4 or pi over 3. Huh?
4.
Pi over 4?
4, yeah.
Okay, pi over 4. Cosine of pi over 4 is root 2 over 2. That's positive. Sine of pi over 4 is root 2 over 2 times 2. Is root 2 minus 1. Positive. Positive times positive is positive. Okay, what's a good number to pick between pi over 2 and 5 pi over 6? You got 2 choices, 2 pi over 3 or 3 pi over 4. Okay, 2 pi over 3 I heard. Cosine of 2 pi over 3 is negative half, that's negative. Sine of 2 pi over 3 is root 3 over 2. Root 3 over 2 times 2. Root 3 minus 1. Positive, negative times positive. Mr. Park, they're alternating. Yeah, sometimes it does alternate, but there is no pattern. What's a good number to pick here? Pi. If you can pick a quadrantal angle, that's the easiest. Cosine of pi is negative 1. Sine of pi is 0. 0 minus 1 is negative. Negative times negative?
Positive.
Positive. And then less than 0 means here, so what would your answer be? Your answer would be 0 to pi over 6. Then pi over 2 to 5 pi over 6. And then from 3 pi over 2 to 2 pi. Mr. Park, how come it includes 0 and 2 pi? Well, if you plug in 0, didn't it come out negative? And that's what we want, right? Less than 0 means negative, so that means 0 makes it negative. So that you should include 0. So there will be one inequality on the test. All you gotta do is solve it like an equation, put those numbers on the number line, and test. But see how, if you don't know your trig values, it takes so long to do it. Okay, that's all the hints I'm gonna give you for this test. So you know there's gonna be logarithms, magic number, basically everything's there. And there's proof-like problems now. There won't be any proof, but it's gonna be like simplify. Did I show you that yesterday? I did, right? I did. All right, we'll play one game and then we're done. Should we play one game? I made one game today.